4-6, completing the square. So our objective for this section is to solve equations by completing the square. This is another way to solve quadratic equations. Previously, we saw that we could solve them with factoring or with graphing. Here we are going to try to solve them by completing the square. Okay? And we also are going to learn how to rewrite functions by completing the square, mostly by turning them into vertex form. Okay, our essential understanding is that completing a perfect square trinomial allows you to factor the completed trinomial as the square of a binomial. So what does that mean? Well, that means that we are going to have some sort of quadratic, and we are going to change it from ax squared plus bx plus c, something like that, and we are going to make it so that it looks like a plus some number, could be anything, squared. Okay? Changing a trinomial to the square of a binomial. Okay? We are going to figure out what I need here and complete the square. Okay? So, first, you can solve an equation that contains a perfect square by finding the square roots. The simplest equation is one that looks like ax squared is equal to c. And in order to solve this equation, okay, we get x by itself. So x squared is going to equal c over a. And then to solve for x, we take the square root of both sides. Remembering, of course, that when we take the square root of both sides of an equation, we have to include the plus or minus. And that should make sense because we are going to get two answers. The two answers are going to be the ones that where the function actually crosses the x-axis. Okay? So let's start by finding the solution to this equation right here. Okay? What you should notice is that I have an x squared term and then just a constant term. There's no x term. Just like back here, right? This form was ax squared. There was no b term. There is no x by itself. So in order to solve this, all you have to do is isolate x squared and then take the square root of both sides. So to do this, I subtract 10 from both sides, get 4x squared is going to be equal to 36. Divide both sides by 4, and we would get x squared is going to be equal to 9. So taking the square root of both sides and remembering that I need a positive and negative answer. So my answers become plus or minus 3. Okay. Now, in these problems, they don't always have to work out perfectly. So with this problem, I'm going to do the same thing. Looking at it, I realize that I have no x term, so I'm going to try to get x squared by itself. So to do that, I'm going to add 5 to both sides. I'm going to have 3x squared is going to be equal to 30. Divide both sides by 3. And we have x squared is going to be equal to 10. And now when I take the square root of both sides, it doesn't work out perfectly, but that's okay. X is going to be plus or minus the square root of 10. Okay? So with both of these problems, okay, we are isolating the variable, and once we get it by itself, we do the opposite of squaring something, which is taking the square root. Okay? Let's look at a word problem. Okay? So in this word problem, we are designing a house. An architect used the windows like the one shown on the right. What are the dimensions of the window if it has 2,766 square inches of glass? Well, when you see the word square inches, that should mean area to you. Okay? So we want to find area. I want to find the area of that window and then the area of that window. And then the area of the whole thing is just the two of those added together. Well, I can see that the rectangle is nice and easy. That's 2x times x. So that's 2x times x, which is 2x squared. Okay, well, next. Okay. Remembering, of course, that the area for a circle is pi r squared. Okay. Now my radius, if I look here, the diameter is x, so my radius is going to be x over 2 squared. But I don't want the area of a whole circle. I only want the area of half a circle. Okay, and then when I add those two pieces together, I'm going to get 2766. Okay. I can solve this fairly easily. Okay. Let's see how we do it. Okay. So first, let me simplify this piece right here. Okay. I want to square x over 2. So, well, first here, I'm going to have pi. That's going to be x squared over 4 over 2. But if I want to divide by 2, that's the same thing as multiplying by 1/2. Okay? So this expression can turn into, and that's going to equal 2766. This expression turns into 2x squared plus the 4 and the 2 multiplied together. We have pi over 8. X squared is equal to 2766. Okay. So next, I should see that this has a common factor. So let's factor it out. And I'm left with 2 plus pi over 8 is equal to 2766. Now, this shouldn't be too intimidating. I could divide both sides by 2 plus pi over 8, or I can change that into a decimal. Okay? I'm just going to divide it out right now to be more accurate. Over 8, which would cancel. Divided by 2 plus pi over 8. Okay? And now, all we need to do is plug that into a calculator to give me x squared is going to be equal to 2766 divided by 2 plus pi divided by 8. And right out of my calculator, I get that x squared is going to be 1156. Okay? And of course, we take the square root to get plus or minus 34, I believe. Yes, 34. But we don't need the negative because I am trying to figure out the length. Whoops. I am trying to figure out the length. I'm trying to figure out x, which is a distance. So I don't need to worry about the negative 34. All I need is that x is going to be equal to, put it in blue, 34 inches, which means 2x is going to be 68. Okay, so we used what we know about squares to solve an actual word problem. Okay, next, okay, sometimes in an equation we have a perfect square trinomial equal to some sort of constant. To solve this, factor the perfect square into the square of a binomial, then find the square roots. So what that means is if I recognize that I have a perfect square trinomial, I can factor it, take the square root of both sides, and solve. Okay? Like this problem right here. Hopefully you can recognize that that is a perfect square trinomial. I can factor that. The factors of 4 that add to 4. That's 2 times 2. It's a perfect square binomial. So that gives me x plus 2 squared is equal to 25. Okay? Now from here, I can take the square root of both sides to give me x plus 2 is equal to plus or minus 5. You still have to include both the plus and the minus. Subtracting 2 from both sides gives me 2 answers. Positive 5 minus 2 is 3, and negative 5 minus 2 is negative 7. Okay, still going to get 2 answers. And don't forget what these answers mean. These answers mean that the quadratic, okay, the graph of the quadratic is going to equal 3 and -7 at where it crosses the x-axis. And because these numbers worked out so perfectly, I could have actually approached this a different way. I could have set it equal to 0 and tried to find the factors of -21 that subtract to 4. And I would have gotten 3 times 7 is -21. 3 minus 7 is 4. Okay? So this would have worked out for me if I had tried to factor it. Sometimes this works, sometimes it doesn't. Okay? It depends on the problem. But there are plenty of problems when we try to complete the square that don't work out perfectly, which is why this is a good method to try to use to solve equations that don't quite factor. Okay, so let's talk about completing the square. So looking at this, we have x plus bx. We have that right down here. Okay, we can see that is not a perfect square. It's a perfect square with a little bit extra, right? It's not part of a perfect square trinomial. It's almost. Okay, so we can use the coefficient b, this coefficient right here, this one right here, to find a constant c that we do have a perfect square trinomial. Okay, when we do this, we're completing the square. And you can see what happens here. I take b, I divide it by 2, and then I add this little square bit. Okay, so I'm taking a squared plus bx, and I'm adding to it b over 2 squared. And now when I add that little green bit right there, I do have a perfect square binomial. Okay? That's what we mean when we say completing the square. Okay? So the number that completes the square, and you can see that right here, you can form a perfect square trinomial from ax squared plus bx by adding b over 2 squared. Always adding because we're squaring something, so no matter what, we're going to make it positive. Okay? And then, of course, my factored form becomes x plus b over 2. The whole thing squared. Okay? So, what value completes the square? Look at this term right here. Divide it by 2, which is 5, and then square it. So a plus 25 completes the square. Okay? Let's look at a few more. Okay? So complete the square. Take the middle term, divide it by 2, we get 1. 1 squared is 1. Take this term, divide it by 2, we get 2. Square it, we get 4. Take 100, divide it by 2, and square it. Get 2,500. It's okay to get a big number. The middle term is a big number. 10, just like the above problem, divided by 2 and square it, we get 25. 12 divided by 2 is 6, and square it, we get 36. And then 32, divide 32 by 2, we get 16. Squaring that gives me 256. So, all these numbers on the end right here turn these things into a perfect square trinomial. If I were going to factor the first equation right here, it would factor into x plus 1 squared. If I were to factor the second one, it would factor into x plus 2 squared. Okay? The last one, x plus 50 squared. Okay? And if you FOIL that out, you will get back to this trinomial. Okay? This one over here would be x plus 5 squared. Sorry, that's a minus right there. Okay, x plus 6 squared, and see that negative? That would be x minus 16 squared. Okay, so when we're adding these numbers, we're doing it with the expectation that we are going to eventually try to factor what my new expression. And that will help us solve an equation with this method, with completing the square. So I have a couple steps here. Step 1, rewrite the equation in the form x squared plus bx is equal to c. So to do this, get all the terms with the variable on one side of the equation and the constant to the other side. You must have x squared by itself. So divide all the terms of the equation by the coefficient of x squared if it is not 1. Must be a 1. Next, number 2, complete the square by adding b over 2 squared to each side. Yeah, you're adding it to the left side. You have to add it to the right side as well to keep the equation balanced. Then we factor, then we take the square root, and then we solve. Okay? Let's see what this looks like. Okay? My first step is, well, before I even do this part right here, I always like to check my equation to try to simplify it. Okay? So in this case, I can divide the entire equation by 3 and the right side by 3. The right side stays at 0, so the 3, when I divide the 3 out, it kind of just goes away. X squared minus 4x plus 2. Okay? Then, before I try to complete the square, I always like to see if I can possibly factor this. Does it factor? The factors of 2 that add up to 4. Well, the only factors of 2 are 1 and 2, but they don't add up to 4. Okay, so that tells me that this quadratic is not going to factor evenly, which is fine. I'm going to complete the square. So, subtract 2 from both sides to get the variables by themselves. X squared minus 4x is going to be equal to negative 2. Next, I am going to complete the square. I look at the middle term, which is negative 4, divide it by 2, and then square it. So it's negative 2 squared, which is a 4. Okay? I now have a perfect square trinomial on the right side, but you can see that I've added an extra 4 to this equation on the left. I need to keep the equation balanced by adding it on the right as well. Okay? Factoring my trinomial gives me x minus 2 squared is going to be equal to 2. Negative 2 plus 4. Okay? Take the square root of both sides, and we now have x minus 2 is going to equal to plus or minus the square root of 2. Okay? Can't simplify that at all, which is okay. And I add 2 to both sides. Always leave the rational part first, and then the irrational part. So my two answers are 2 plus radical 2 and 2 minus radical 2. And again, remember what that means. Those are the 2 points on the x-axis where the graph of the parabola crosses the x-axis. Okay. Finally, we can complete the square to change a quadratic function to vertex form. This is another way to change a quadratic from standard form to vertex form. Previously, if I wanted the x-coordinate of the vertex, I would do negative b over 2a. And then the y-coordinate of the vertex would be f of negative b over 2a. Okay? There's another way to do this. We can use the techniques of completing a square to find the vertex form of the equation. Remember, vertex form looks like x minus h squared plus k. And then from when the equation is in this form, is in vertex form, I can just look at it and tell what the vertex is. The vertex is h and k. Okay? So, just looking at this, I can't really tell what the vertex is because it's not in vertex form. Okay, so let's try to put it in vertex form. Let's do it by completing the square. X squared plus 4x. Now, to complete the square, I would need to take 4, divide it by 2, and square it. Plus 4 completes the square. Well, I need the rest of my equation. I need minus 6. But I've added 4 to the equation, as you can see. So I need to add it to the other side, which I don't want to do because I want to make sure that y is by itself. Or if I add 4, I can just take it away. And now this equation has stayed the same. The reason why I want to change it like this is so I can factor this first piece. So now I have y is equal to x plus 2 squared minus 10, which makes my vertex -2, -10. Remember to reverse the sign right here because the equation has an x minus h. Okay? And my y-intercept is still going to be -6. Remember, don't forget about that. Now my standard form, my y-intercept is -6. Okay? And that is 4-6, completing the square. Useful techniques to solve an equation, especially when we have something that looks like this, where we have a 1 in the front and it is not factorable. Useful technique. If you don't like it, the next technique that we will do, the quadratic formula, will also work.